Hey class, in this video I'm going to be talking about some basic platformer physics. It's nothing really fancy, we're just going to be adding some jumping and some gravity, but it is sort of like the beginning of thinking about physics in a game. Hopefully we'll get to some more complicated physics this semester, but this is usually where we're going to start. I'm just going to keep working on the scene that we had in the last video. We have some new scenes in the video or in our program, and so the game scene, we're just going to work on that one to add some actual, interactive game dynamics. I'll try to keep it simple, but also try to make something that's engaging as a game. Let's get started. I'm gonna go over to GitHub as usual, and there we go. We have a nice clean repo. I don't really need to duplicate my files because I'm just working on project 1-5, which I started in the last video. So I'm just gonna go ahead and click open in Sublime Text and open 1-5. And go to sketch.js. I think my Sublime server is running, just want to make sure. And then I'll open up a new window. So let's go to localhost 8080. And I don't have the link yet. I'll do that at the end of the video. So for now, I'm just going to type this in, project 1-5. And I'm going to make this a bit bigger. Okay, that looks good. Let's make the console a little bit bigger. And hopefully it still works. Yeah. Okay, so we can go into our game. So that's nice. Can we go over here? Okay, so we'll update that in a bit, but let's make our game scene first. So I'm gonna just collapse some stuff. And so we're just gonna build this simple game scene. I have a couple of new graphics to add. I just made those. I'm not gonna videotape any more Pascal tutorial stuff because I think you guys basically seem to know how to use it, and if you're using your own art programs, so I'm not too worried about that. But if you do want more Pascal stuff in the future, let me know. So I'm just gonna go to my project folder. There's my project folder, and then I made a couple new assets on Pascal. I made a jumping animation for my character. I don't think it's actually gonna look that good, but again, I just did it pretty fast just for the sake of the demo, so I'm gonna drag that in there. And then I have this like bad guy, which is this like snake. Just kind of the first thing I thought of. Obviously didn't spend very much time on the graphics. You guys should, spend as much time as you need to get something that you like the way it looks. But, it's not bad. It looks like a snake. And so that's fine for now. So I'm going to throw that in there. And so obviously I need to load those things to start. So anytime I add new images, I just want to make sure to add them in here. So I have the Jerry idle, Jerry walk, and now I'm going to add Jerry jump. So you don't have to put the variables in the same place, but it's nice if they're kind of organized in the same place. And so then I have my tree image, my cloud image, my sign image, and let's add my snake image. Okay, so that looks pretty good. So then I'm going to go to my preload function and make sure to preload those images. So I'll put Jerry near Jerry jump, and that's load image jerry _ jump .gif. And so these are both GIF animations. So I'm using .gif for both of these. And then for my snake, I'm going to say snake image equals load image snake.gif. So I only have one. Could add later if I want. So yeah, I've got my images ready to go. And I'm going to have some global variables to start with. That I'll be using to do my physics. So I'll do a quick overview of what's going to be happening with the physics. I'm going to open up a new tab so I can do this on a blank screen. So we're going to create a simple platformer. I'm going to have the character running across the ground. So we'll have a ground at the bottom. And to create a platformer, there's a lot of different ways to do it because you could do it in different perspectives, using different styles of physics, different things like that. But I'm just going to do it in a really simple way where I'm going to have my character here, and he's going to be running along, and there's going to be snakes coming at him this direction, and he just has to jump over each snake, and if he hits the snake, then it's over. So it's like the most simple version of a game. Games are complicated enough, but once you get the basics down, you can start to see how the game dynamics work and then begin to add new things. So what do we need for this to work? For a jump, we need the character to have gravity, right? Jumping doesn't work without gravity. If we could jump and just keep going up forever, that wouldn't make sense. To have a jump, we need a downward force, and we call that downward force gravity. And gravity is actually more complicated than it sounds like. You probably think gravity is just like, it sticks you to the ground or whatever. But the way gravity works is it basically uses something called velocity and acceleration. I don't actually remember what it is. We could look this up real quick. Gravity. Let's see. Gravity. Okay, gravity or acceleration due to gravity is 9.81 meters per second squared. We're not going to use that exact figure because we're not, using actual like physical reality in this game. We're just drawing stuff, but we're going to use the basic idea. So what is acceleration? Acceleration is the change in velocity over time. That's kind of easy to do with a game because time is very simple in a game. We have frames. And so if our character is jumping, we're going to apply a jump value in this direction. So let's say that gets the character to like here. If we just had the character drop down like 2 pixels every frame after that, it wouldn't look like they were falling. It would look like they were floating because they would be, just going at one pace. The way that gravity works is it actually adds to velocity. So if your velocity, let's say this represents 10 pixels. If your velocity is 10 pixels downward and your acceleration is 2 pixels per frame, that means, you'd start at 10 and then you'd go to 12 and then 14 and then 16 and then 18, and then eventually you're going to hit the ground and you'll stop falling. So the way that gravity works is acceleration. It's the rate of change over time, or in our case per frame. And so that's how you get the effect of falling, because you go faster and faster and faster until you hit the ground. So that's how we're going to realistically recreate gravity. And that's basically what we're doing in video games. Obviously, in the game, we're just drawing stuff on a screen. There's no real gravity. There's no real acceleration. We're using our observations of those physical events in real life as sort of a basis or a blueprint or a concept that we can recreate using our code and using numbers and images and stuff like that. So that's the basic idea. So we're going to apply gravity to the character. And so we're going to have to add some new variables. We can, put our game physics here. So we need to know the ground is sort of important because we don't want to fall through the ground. So after the ground, we have gravity. So we could style this like gravity, if we wanted to use like the P5 or programming convention of using all caps for constant variables. Actually, ground y technically would be a constant as well because we're not going to change the ground. Although I might change the ground in different scenes. So I'll leave ground as is, but gravity is not going to change. So let's say our gravity is just like 2 pixels per frame. We can always update that later. And so I'll just put a note here, acceleration 2 pixels per frame. So then we want the fall speed, like how fast Jerry falls generally. We can say Jerry fall speed. Or we could call it like Y actually, because we're going to apply it in both directions. So let's just call this jerryYSpeed. We'll leave jerrySpeed as it is for the main scene, but this will be jerryYSpeed. And in this scene, Jerry's only going to be moving on the Y-axis, so we don't really need the X there. So let's say the Y speed, let's just start with 2 as a basis as well. So those are our values for our physics. The ground Y is also being used to tell us where to draw the ground, but it's going to end up in the same place. Let's go down to our game. And so a lot of the game is going to be simpler to the main scene, but there's going to be some differences. So after we draw the clouds, we can just do our jumping and falling. Okay, so the first thing that we really need to know is whether or not we are jumping. And actually, that's another thing that we need in our global variables, because we need to know if the character is jumping if we want to restrict how much they can jump. So I'm going to make one more variable, Jerry is jumping. This is kind of like the Jerry is walking variable, where we change the animation. It's actually going to do that as well. But Jerry's jumping is important because we also want to make it so he can't like jump a million times. So we're not going to allow him to jump if he's already jumping. So if you did allow him to jump, he could just jump forever. And you might want to have a game where the character can jump forever, or they can jump twice or something like that. In this case, I'm just going to allow him to jump once at a time. And so I'm going to start with a jerryIsJumping variable, and I'm going to set that to false. So he's not going to be jumping when we start. And it does need to be global because it is going to go through like multiple frames. If he's in the air for like several frames, we need to know that. So we have jerryJumping is false. And so if he's not jumping, then, he's allowed to jump. So if Jerry is jumping, and so we actually want to know the opposite of this, so I'm going to put an exclamation point at the front. So remember that the exclamation point is like opposite. So if Jerry is not jumping, then we can test to see if they're hitting the key. You can use whatever key you want for this. I'm going to use the space key. And this is actually a compound condition. So if key is down or and key is down, space I don't think has its own variable in P5. So let's just find out. The space character is 32. Okay, so 32. So if Jerry is jumping and we hit the space key, let me put a comment, 32 is space. Then we're going to apply some negative force to the y value. Remember that in our scene, y is 0 up here. So we're going to apply gravity in the plus direction. We're going to apply a jump in the negative direction. So we'll say jerryYSpeed equals, let's say like -40 or something like that. That might be way too much, but we can always adjust that later. Okay, so that's going to make Jerry jump, and then we have to test if he's falling. So we only want to make him fall if he's not on the ground. So if jerryY is less than wherever the ground is, which is height minus ground y. Okay, so let's say apply gravity. So if the jerryY value is less than the height minus the ground, so what that means is if the height minus the ground, it's actually not this line, but it ends up looking like this line because Jerry's standing like right here because Jerry draws from the middle. But we can still use this line so to make Jerry stand here. So as long as Jerry is like above this, he needs to fall. So if he's at this or the same, he's good. He can just stay right there. But if he's above this, we need him to fall down to apply gravity. So that's this logic here. If Jerry is less than height minus ground y, then we need to apply gravity. For this, we don't just apply it directly to speed because we have acceleration. So we say jerryYSpeed plus equals gravity. And then after that, we apply the overall speed to jerryY. So we say jerryY plus equals jerryYSpeed. Most of the time, jerryYSpeed is just going to be 0. He's just going to be sitting on the ground. But if he jumps up, he's going to be going up in the negative direction for a while. And then we'll start to apply gravity, and he'll slowly come back down again. So let's test that and see if it works. So I have to go over here. So let's say else. So if he's still falling, that means that he still has a speed. So we actually need to reset the speed. So if he's at the ground, let's just go ahead and say jerryYSpeed equals 0. So that way he won't be falling anymore. So let's try that again. Okay, so now he's not falling anymore. Okay, so I think actually the problem here is that we need to jump after this. Oops. So if we apply the jumping after this, then we won't get stuck with setting jerryYSpeed to 0. Sometimes we have to play around a little bit with how this works. So let's try that again. Okay, now we can jump. That looks good. This actually looks pretty good for this browser size, but it's probably like a pretty large jump. So maybe we can just change this to like 20 or something like that. Okay, that looks a little bit better. So part of the problem here is I can jump forever. See how I can just keep jumping and jumping and jumping? And that's because the jerryIsJumping is just still set to false. I never set it to true. So once we jump, we got to set jerryIsJumping to true. So we're jumping. So now that will prevent me from jumping more than once. But now I can't jump at all. I have to set it back once I hit the ground. So once I hit the ground, which is here, right? If Jerry is not less than height minus ground y, that means we're on the ground. Okay, so let's put a comment here, Jerry on the ground. So the y speed is 0, and then Jerry is jumping is back to false because he's not jumping anymore. Okay, so now I can jump, and I can jump again when I hit the ground. And now actually it kind of seems like he needs a bit more. So let's go back to 40. And once we add in our obstacles, we'll see we have to kind of balance how much we let him jump. So game dynamics, once we get the basics down, there's this level of like balancing things to make things easier or harder. So that's the basic gravity. That's the basic jumping. That looks pretty good. We want to draw Jerry jumping if he is jumping. So we can do that down here like we did with the walking. So if Jerry is jumping, then we'll use this same image function, but we'll change this to Jerry jump. Hopefully that'll look okay. Else, Jerry walk. And again, we're using a lot of, it's very simplified. We're only using 2 images in the scene, just like we did in the main scene. You can make this more complex by adding more images and more animations and using, either another Boolean or some kind of state thing, which some of you guys have already done in your projects. Okay, so now we can see the jumping animation. It looks okay. It looks like a jumping animation. It's a little bit too long. So if I wanted to change that, I might make it a little bit faster just so we see the whole jump cycle. But this kind of has the effect of making it look like there's different jumps. So that might be kind of useful as well. But either way, I'm just going to leave it as is. So he's walking and he's jumping. So that's Jerry. That's the basic physics for this. You could make him walk back and forward if you want to and change his position on the screen. But to simplify things, I'm actually just going to leave him in one position. Right now, without anything in the scene, it looks like he's just kind of standing still. But we are going to add the little snake guys, and they're going to be going this way. So that will give us sort of the illusion that Jerry is actually moving to the right through this kind of like field of snakes. So those are going to be our obstacles for the game. Let's add those in now. We're going to need a couple new variables here. One is like the number of snakes that we'll have in the scene. And then we need the X values for those snakes. So we're going to use another array for that. So I'm going to close this for a second and just go back up here. So we have our like tree images, background images, cloud positions. So I'm going to make another variable for our snake position. So I'm going to say snake. And we're actually only going to use X values for this, but I'll make it positions in case you want to use Y values if you have like a different directionality to your game or something like that. And this is actually just going to start out as an empty array. So we'll add in X values here. So I'll say add snake X values here. And we'll change this every time we create a new version of the game, so it's not always the same. So I'll go into the setup game function. And so I'm going to position Jerry. Let's put a comment. I didn't write this down last time. Save Jerry's map position. Okay. Move Jerry to game ground. And then now let's say add snakes. So the first thing we're going to do is actually just reset the snake positions because we do have the ability to restart the game. And so I'm just going to start by setting the snake positions back to an empty array. So this is going to reset all snake positions. And then I'm just going to choose a number. So I'm going to say variable snake number. And I'm going to use a random here. So I'll say, somewhere between 8 and 12 snakes. And something that's nice here that you could add if you want to add some more dynamics to the game is when you set up the game, you could actually change the number of snakes that you see. And so you could make the game section longer or shorter. So anything that you can really change here, you could turn into an argument to set up your game, to set up these different sections differently. So then I'm going to use a loop to add my snake positions. I'm going to say for let I equals 0, I is less than snake number. So whatever that number is how many snakes we'll add to the scene, I plus plus. And now I'm just gonna add these positions. So I'm gonna say snake positions and then dot push. So I'm gonna add them one at a time. And I'm just gonna choose a random X value, but I'm gonna base it on I. So the way that I'm gonna create this is, remember that I is counting up. So let's say this is our scene here, and here's Jerry here. I want there to be a snake on the screen as soon as he starts. So I'm gonna have a snake somewhere over here, just so we know what's going on, that there's a bad guy. And so that's gonna be somewhere between width over 2 and width. So that's what I'm gonna start with. A random value between width over 2 and width. And then I'm gonna add to that. So each successive snake, I want them to be like at least, another width away, but not like completely randomly. So I'm gonna say like, I is gonna be 0 here. And so then I is gonna be, let's say this is I. So I is gonna be 1 here and 2 here. So I'm just gonna add another width for each I along with this random number. So it'll basically be like 0 plus a random number, whatever width is plus a random number, whatever this is plus a random number. And so as my snakes are coming towards the character, we'll see them like kind of one at a time, but there'll be some irregularities because one could be over here, one could be over here, but it's still slightly predictable. So we want the game to be playable, but if it's completely random, you're going to end up with situations where, there's 2 snakes that are like right next to each other and the player won't be able to jump across, and that'll make the game impossible. So we want to make the game hard, but we want to avoid situations where it's impossible. So let's add that code in. So I'm going to use I times width over 2. So there'll be a new snake every like half thing. And I think that's all I need to do there. So this is a little complicated, so I'm going to put a comment here. So add an X position for a new snake, half a canvas away from one another, plus random value. So that's what that math is. It's a little bit complicated. There's a lot of ways to like vary this to get different things. So if you're interested in changing that, we could think about how to do that. So that's how we're going to add the snakes before we start the game scene. And it is a good idea to put this before we get scene equals game, just so we've got everything ready to go before we change to that scene. So let's close this. And now we've got to draw the snakes. And so, just with any other part of our program, there's drawing and then there's like, changing stuff. So I'm just going to draw the snakes here. I'm going to say for let I equal 0, I is less than snake positions dot length, I plus plus. And so X is just going to be snake positions at I. So I'll just write that out just so we know it. And then I'm going to draw a snake at X. So the snakes are always going to look the same and do the same thing. The only difference is their X position. And then I'm going to say snake positions at I plus equals, or actually the snakes are going this way. So that's negative on X. So let's say minus equals. And so for the speed of the snakes, I guess let's try 5. And if that's too slow, we can always speed it up. And so this function is our specific snake function, which is going to draw the snake and detect collisions. And that's just almost exactly like our sine function, except something slightly different is going to happen when we hit the snake. So I'm going to scroll down here. So we have this sine function. It's literally almost exactly the same thing, which it might make you think, oh, why do I have to repeat this code over again? Being able to reuse this code is a little bit more complicated. It gets into some concepts like inheritance and polymorphism, which probably sound like big words, but we are going to talk about that this semester. So we'll get into a later video. For now, I'm just going to kind of copy this pretty much. So for our snake function, we have function snake. We only get the X value. The Y value for all our snakes are going to be the same. So let's calculate the Y value. We're just going to say let Y equal height minus ground y. So similar to where our player is. So they're all on the same plane. That's another thing you could create some variation, is have different obstacles at different levels in the y-axis. I'm going to keep it simple for this one, but that's something that you could add as well. So then I'm just going to draw the snake. So I have the image function, snake image, and then x, which I'm getting as the argument, and y, which I get from this calculation. If I wanted to have different snakes, I could also, randomize this image or have a different argument here as well. So then I'm going to do the collision. And because I'm using x and y like I did with my sign, I did that on purpose so that I can just copy this if statement here. So I'm just going to copy that and paste it down here rather than writing out the whole thing. So if we collide with the snake, then Jerry's going to die. So once I paste that in, jerryX is the same, jerryIdle, all that stuff is good because all of my Jerry images are the same width. The sign is different size than the snake, so that's one thing I need to change. So I'm going to take the snake and swap that out. And then I should be good to go. I'm just going to change the scene. So if we lose, change the scene. So I'm going to say scene equals lose. And if you want to do more here, I recommend creating a separate lose, setup lose function if you want to add points or take away points or do something else like that. So let's try this now. So I'm just going to test to make sure the snake kills him. Okay, so you lost. There is a little bit of space here because the snake, there's probably a little bit of like alpha right here. So if you wanted to like make sure that they were overlapping a bit here, you could actually play with these values a bit. Like maybe I could do width over 4, height over 4 here. Because they're on the same plane, I'm not really worried about their Y collision quite as much, although he can jump. But that way, okay, that looks a little bit better. They're actually colliding there. So that looks nice. We could also draw the snakes on top of Jerry if we want it to look like the snake is, attacking him on top. So if I wanted to draw the snakes on top, I would just move this for loop down here. So let's see how that looks. That might look better. So, just a P5 thing, the order of the graphics. So that looks pretty good. It looks like the snake is kind of getting him. And if I hit R, that does restart the scene. So now we can jump and still get hit. So I actually think that jump is too high, although I only barely make it past the snakes because the snakes are moving pretty slow actually, but it's pretty easy. So if it's this easy, you might want to, play with some things. So I could make the snakes faster. That actually makes it easier in some ways because if the snakes are faster, I don't have to clear as much space. But I could also make the jump lower. So I can make the jump lower, maybe try like -30. Oh yeah, that is probably too hard. But it looks a little bit more realistic. The other jump is really high. So let's make the snakes a bit faster. So this is both going to make it a little easier and a little harder because the snakes are going to be faster, so they're going to come quicker. But they'll also, if we jump over them correctly, our jump gives us a little more space. So that's a little more challenging. I'm hitting space a bit more, but I'm also not losing too bad. Okay, there's 2 snakes in a row. That's good. I made that. So yeah, it's pretty easy, just kind of simple, but there's a lot of things that you could vary here, like the snakes could have different speeds. We could even just put some, like a random value here. That's probably gonna look bad. Let's just try it, see what it looks like. I think it's gonna look too jittery. Yeah, they kind of look like they're like squirming along. So I'm just gonna leave that. But there's a lot of things that you could do here to add variation. You can change things, and you also don't necessarily need your snakes to be, obstacles. Like sometimes good things could happen to the player when he runs into stuff. Like you could make it so that he has like potions that make him jump higher, different things like that. So then when you would have the function snake, instead of changing the scene to lose, you could, say Jerry Y increase is, +5 or something like that. So you could add different things. You could also do stuff like have Jerry have like a certain number of lives so he can get hit like 3 times before he loses. There's a lot of different variations that you can add on top of this once you kind of have the basics down. So that's our snake. One last thing that we need to add in here is when Jerry wins. So the way that Jerry's going to win the scene is just if he gets past the last snake. So again, you might want to add something else in here, like he gets to a treasure chest at the end or something like that. But for this one, I'm just going to add in, once he gets past the last snake, then he wins, just to kind of keep it simple for here. So that I'm going to do some calculations up here in my main game function, just so I can see that here. So I'm going to make sure it's the last snake. So I'm going to say if I equals snake positions.length minus 1. So remember that the array with our snake positions, the last one is always going to be minus 1 because the length is one more than the index because we start counting at 0. So if Jerry gets past last snake. So if I equals snake positions dot length minus 1, so we're at the last snake, and Jerry X is greater than X. So the X in this case is the snake X, and so all of the X's at the beginning, you know, Jerry is like right here at like 200 or whatever. All of the other X's are back here going this way. So if every single X is lower than Jerry, then we know that we've passed all the snakes. Scene equals win. And the win scene will take us back to the main scene. Okay, so if we win this time, okay, you win. It's kind of like in the middle, so I could add a little bit to that so he gets back to the ground, but it's kind of fun that he's jumping. And so if I hit M to return to the map, okay, notice that I'm down here. So that's the last little bit, is that we want him to be back up here where he was when we left. So that's the last thing we have to fix. So that's in setup main. This is because I'm resetting the game to jerryX, jerryY. So this is actually a good chance to use an argument. So this is kind of complicated, but basically what's happening here, if I can explain it real quick. So here's my main scene, and Jerry's like here. And then he plays the game, and he goes down here, and we saved, you know, MX, MY. But then he loses, right? So you lose, start over. This was kind of dumb of me. But so if I lose, then I do the setup again. So main X, main Y gets set to this. So that's because I did the setup game. Once I lose, to reset, I hit R and reset. Now this position goes to MX, MY. And so then when I won this one, and that's when I finally go back to the main scene, now that's why MX, MY is here. So I'm going to have to, this isn't the best way to do this, but it's going to be the quickest way. I'm just going to add an argument here to say if I'm coming from the main scene. So I'm going to say from main. So I'm going to say if from main, then we're going to save the main X, main Y, and then else, you know, it's just going to ignore that. So we won't overwrite the main X, main Y. And then I have to go to the sign function. This is where it's starting to get kind of annoying. But from the sign function, if I set up game, I'm going to say it's true. It is from main. And if it's from the lose function, I'm going to say it's false. It's not from main. Okay, so let's test that one more time, and then we'll almost be done. So I lost. I'm going to try to win. Okay, I win. So now if I did that right, he should go back to here or here, wherever he was when he left. Nice. Okay. So now you could do something where we say, okay, we've defeated Snake World, so let's, you know, change that. But I'm not going to do that right now. We're going to do that when we get to a slightly more sophisticated version. So go back to the map. Okay, so then let's test if I go over here. Okay, so now I can go here, and there we go. So, okay, so we can add some more arguments to our setup game if we want to change the scene so they're not all exactly the same. So I'm just going to change a couple things just as some examples, but really you can change anything about the scene. You can change the graphics or the type of enemies that are being drawn or whatever it is you want to do. I'm going to just do a couple simple things. I'm going to change the number of snakes just to change like how hard it is. And then I'm going to change the background color just so, you know, you can tell that it's a different scene. Really simple, but you guys can use graphics or do a lot of other things. To change the background color, I'm just gonna start here. I need a global background color because when I reset the scene, I'm not gonna be able to remember which background color I set with the sign. So I'm gonna start with that. So let me collapse some of these guys. So it's a bit confusing, but it's good to kind of go over this. And again, I know I've said this a million times, but it's going to be much simpler when we introduce objects. So I'm going to start with a BG color for the whole scene. I'm just going to start with light blue. That's where, that's kind of the default I had. And then this needs to be a global object. So the reason is because there's a lot of different ways to get around at this point. And this is going to sound complicated, but this is actually like really simple compared to how a lot of things work. So we have our main scene here, main, and we have our BG color here. Okay, so then we have some signs, and each one of them is going to have a different BG color. So let's say this one's red, this one's green, and this one starts out as blue. Okay, so when our character clicks on this one, we go to a setup function to set up the game. And it's going to say BG color gets green. The problem is when we lose. So once we set up the game, we play the game. And then if we lose, we go back to setup. Okay, so in setup, now we don't know which sign was clicked because we're in this one. So how do we know this is green now? So that's why we need the global variable. So once we set that to green, it's going to stay green. And it's going to keep being green until eventually, if we win, we go back here and we go click on the red one. So that's why we need a global variable here, even though we're going to use arguments for our signs. We have our BG color is light blue. That's one thing that I'm going to change. And then I'm going to set a color for each one of my signs. So in the main function, I have my sign functions. So let's say the first snake world is the easy snake world. And then I'm just going to do, for the second two signs, I'm kind of deleting my whole narrative from last time, but that's okay. Then medium snake world, and then hard snake world. And so for the colors, for the easy snake world, we're going to stick with light blue. So I'm kind of repeating that, but that's fine. And then for the harder snake world, let's go darker. We'll say purple. And then for hard snake world, we'll say dark blue. So we'll get kind of darker as we go. So when we click on the sign, or when the character hits the sign, then that we need to add this argument. So I'm just going to put BG for BG color in here. And so if we do set up the game, we'll send that argument again, BG for BG color. So I could just, change the color right here. But remember, I want to make sure that everything that happens to set up the game happens in the setup game function. So we're kind of passing this argument around. It's a little silly, but that's fine. So then in our setup game function, we're going to get that BG color from the sign function. And so I'm going to say the BG color global equals BG. And then for my game function, I'm just going to use this BG here. So let's test that. Okay, so I have my, oops. Oh wait, this is BG color. So I have my, I got an error because I forgot to put in that first argument here, which is false. This one is true, coming from the main. So yeah, the sign setup game is true because it's from the main section. The lose one is false. Okay, so now if I go into hard, okay, that's the dark blue color. Easy is light blue. That's good. And purple. So that's cool. This again is just a really simple change. You guys can change lots of other different things, but I just wanted to show visually that the scenes are different. And so then a simple thing we can do to change how hard the scenes are is when we set up the scene, changing this snake number. So we're going to make this global as well, but also add some arguments to change it. So we'll have a min snakes, So let's say the minimum number of snakes for the easy level is like 3. And a variable max snakes, let's say it's like 6. So here we'll say min snakes and max snakes. And again, we need these to be global variables because if we reset the game, they need to still exist. So then for our sign function, after the background, we need min snakes and max snakes. So let's start with, sorry, I know I'm scrolling around a lot again. So let's go to the main function. Okay, so after light blue, we have our min snakes and max snakes. So min is 3, max is 6 for easy. For medium, let's do 7 to 10. And for hard, we can do 11 to 15. And we can always go back and change these if we want. So those are our 3 signs. And then again, we need to add these arguments. So we have min and max. And I'm just going to use the abbreviation. We can remember that these are for the snakes for now. And then again, we're just passing it through here, min and max. So again, this looks a little bit silly, but it is going to be useful in the future. And then again, for our lose function, we need to make sure that it has arguments, even though it's not changing the arguments. So we're just using the global BG color here, the global min snakes here, and the global max snakes here. And then finally, for the setup game, just doing the same thing here. I'm going to use the abbreviation first, min and max, and then just say min snakes equals min, max snakes equals max. So it's a bit more complicated. We will look at better ways to do this type of thing very soon, but it does actually kind of look similar to something that we'll be doing later on in the semester, so I think it'll set up that. So let's start with the easy snake world. So there's 1, 2, 3, 4, 5, 6. Okay, that's good. You win. So let's hit M. And then hard snake world, or no, medium snake world. So I think there can be between 7 and 11 here. Okay, cool. Let's go back to the map. And so this is the hard snake world. Actually, I want to take a screenshot while we're doing this, so I'm going to do that. It's going to be hard to do this, so I'm just going to do this here. So use a screenshot, hit R to start again, because that's the last thing. Once we verify that this all works, we're going to go back and add our thumbnail, or maybe I'm just going to give up. Ooh, cleared 2 snakes. So yeah, there are a lot of snakes here. This is definitely the harder level. And finally we win. Okay, let's go to our home page and add a link here, and then we'll be done. So yeah, this one's a bit complicated, but keep in mind you don't have to do exactly what I'm doing. Think of other ways to use the interactivity. Think of other ways to use the physics if you're wanting to do different things here. So I'm gonna close this out and just add a link. So the first thing I need is that thumbnail. So I'm just going to call this 1-5, or I guess I called it V1-5. So let's put that in there. This looks kind of cool. I'm going to delete 1-4. I don't need that in there. I'm going to open up index.html and scroll down a bit and just copy this and paste it, the last project. So we can just swap these 4s for 5s, pretty easy. And so now we have some scenes and some physics. So that's very cool. I actually don't really like the red on this, so I'm going to change that. I'm going to go to style.css. Oh, I guess it's the same that I used here, but it doesn't really look the same. Let's try purple here. See if that looks better. Yeah, I like that better. I'll leave the red as is. Okay, so now I'm starting to actually have a bit of a game going on. So I have different scenes. And another thing to emphasize is that you don't necessarily, most people I think put, making a platform game as something they were interested in. But if you're not, if you just want to build like an RPG game, you can just make different scenes with different collision, different physics. So, different things that you could do is have, instead of having the character die when he hits something, you could have different like potions or spells occur. You could have like even just like visual changes, whatever you guys want to do. I'm kind of just like introducing these concepts, but I do want you guys to feel free to do something closer to what you're interested in making, even if it doesn't necessarily look like exactly what I'm doing in the demo. So I'm just gonna upload this. So I'm gonna exit out of Chrome, Sublime, close all these guys, and just add in a summary here. So adds project 5 or 1-5 link and game physics. Click commit to master, push origin, and that should be good to go. So that's it for this video. Sorry if it was a bit long and complex. Let me know if you have questions, and I'll see you guys in class.